Everyone, and welcome to the ER&L and Pluto Labs Behind the AI webinar. We're so happy that you're here today. I'm really excited to see the community here. We have close to 500 registrants for this webinar, which tells me a lot of things about our community. It tells me how important this topic is. It tells me that we are paying attention, we're asking questions, and we're actively trying to understand one of these major significant technological shifts. So I think this is really important. My name is Bonnie Tijerina, for any of you who don't know. I'm the founder of ER&L, our conference and our community. So before we start today's session, I'd like to spend a few minutes talking about why we're here, how this webinar came about, and what we're hearing from our ER&L community about AI. As part of registration, we asked participants a few questions, and I'd like to share some of that. So this is our agenda slide. So I'm going to talk for a few minutes and just talk about, what kind of questions we have as a community. And then I'll turn it over to the folks at Pluto Labs to dive into answering some of those questions and helping us with some of those fundamental questions. So, why are we here? Um, so, for those of you who registered, obviously you all did. In your registration form, we had asked a few questions. We were just curious about those of you who are interested in participating, why you're interested. And there was a lot of really fascinating answers. So I wanted to start this webinar with a few of the questions and few of uh, um, the topics that you all asked about. So, one of the things we saw is that obviously there's this growing interest in AI. ER&L is often known for kind of thinking about the next thing that will impact the work that we do. You all always have great questions and great conversations when we meet in person. Um, and so what we found is that in our surveys that we have annually at the ER&L conference, we would regularly get questions and concerns about AI. But in 2026, like that has really reached a point where we know there's a lot of questions our community has. At the same time, this was our first year that Pluto Labs came to ER&L, and what they noticed in talking about their company, their products, and what they do is there was a lot of kind of fundamental questions and understanding that still needed to happen in order for us to have the kind of discussions that I think we want to have. And so they came to us and asked if we would be interested in partnering with them to help us address some of those the questions that are sort of underneath some of the bigger questions that we as a profession are going to have. So it was really great timing because ERNL wanted to do more on this, and the folks at Pluto were willing to do something with us. So that's how we got to where we are now. So what we heard in our webinar, go to the next slide, please. So we asked folks why they wanted to attend. The top responses including keeping pace with technological change, improving productivity and efficiency, learning practical applications, and supporting teaching, research, and learning. It really shows, I think these responses really showed like our curiosity, but also our purpose in thinking about AI's impact on our field. We're interested in solving real world problems and thinking about how to better support our community. We also asked about, if you could ask an AI expert, um, questions that we need answered, what kind of questions would we ask? The responses were, I think, really thoughtful. People wanted to understand licensing and copyright implications. They wanted to know how to evaluate vendor claims about AI. They wanted guidance on governance and policy development, practical examples of implementation, and also just help in understanding how libraries can use these technologies responsibly. Um, and then when we looked at the responses in more detail, a few themes emerged again and again. There's a strong interest in AI's impact on collection development and discovery, questions about AI's features being added to databases and research platforms. People wanted to understand what vendors are actually doing when they say they're using AI, and a significant interest in staff training and organizational readiness. And of course, there's a great deal of discussion about supporting faculty and students as AI becomes more integrated into research and learning. Um, there's also, some important concerns. Just skip to the next slide. There's also these concerns about reliability. How do we generate, how do we evaluate AI generated information? How should libraries think about hallucinations and misinformation? What responsibilities do we have around transparency and sourcing? How do we address bias? How do we ensure these tools are being used ethically? I think these kind of concerns I think are really encouraging to me because they are what libraries and information professionals, the kind of exactly the questions we should be asking and exactly the concerns we should be having as we start to navigate the impact of AI on our professions. But I also, I think that there's plenty of opportunities, and I saw that also in the responses. So looking ahead, like I said, this webinar is a bit about building these foundations of understanding concepts. So for some of you, a lot of this might already be information you know. For some of you, this may all be new, and we will provide the slides so you can always access it later if a lot of this is new for you. And so, we're starting here today with building this understanding of AI concepts. But then looking ahead, we're thinking about what ER&L can be doing in this area. So I think there's plenty of opportunities to build a common foundation of AI literacy that can support, part of these larger conversations that I think we as a community should have and we know are coming. So as an organization, we're already thinking about how AI might impact part of our programming. We're thinking about, our webinars like this one and other ones in the future, as well as conference track, peer learning, which is what we do at ER&L all the time in our sessions, as well as community discussions, like through our community connections we do at ER&L, as well as like deep dives like workshops. So this is, something we are looking at. We see this as sort of the beginning. So I'm excited about, where this conversation is going and where we can support each other in doing this, understanding together. And I want to thank Pluto Labs for partnering with ER&L and helping us launch this conversation. Their willingness to share their expertise to help us build this foundational understanding is really invaluable. With that, I'm going to turn it over to Haley from Pluto Labs, who will introduce our presenters. If you have questions, you can always type it in the chat. We'll have a couple times where we can answer a few questions. But your questions that you had originally in your when you registered are incorporated into everyone's talk. So hopefully you'll get answers for some of the questions you had. So thank you all for joining us today, and I'm going to turn it over to Haley.
Thank you, Bonnie. Hello, everyone. My name is Haley, a business development representative at Pluto Labs. We are delighted to have the opportunity to join you today and share our perspectives on AI and its growing role in research and academia. Thank you all for taking your time to be with us. I am also pleased to introduce today's presenters, Junsun Yu, CEO of Pluto Labs, and Sana Kim, CRO of Pluto Labs. First, let me introduce Junsun. Junsun Yu is the CEO and the founder of Pluto Labs and the lead architect behind Synapse AI's multi-agent research system. He's a former researcher at Postech, one of the leading research institutions in Korea, and founded Pluto Labs to reduce bottlenecks in today's research environment and build more efficient infrastructure for scientific research. Drawing on both his technical expertise and research experience, he focuses on how AI can support academic society in practical ways. Today, Junsun will share what librarians should know about the current state of AI, how researchers conduct their research, and how far AI can support the research process. Next, let me introduce Sana. Sana Kim is the Chief Revenue Officer at Pluto Labs. He has spent many years working in the academic industry, building close relationships with librarian and scholarly societies. Throughout his career, he has helped shape Pluto Labs' direction based on real needs of these communities. His focus is on delivering meaningful value to the emerging AI-driven academic landscape while building long-term partnerships with libraries as a trusted collaborator. Today, Sana will discuss AI literacy and explore what AI literacy really means in the current academic world. And now it's my pleasure to introduce our first presenter, Junsun Yu. Junsun, please go ahead.
Okay, thank you for the introduction, Helly. So I will share my screen. So, hello everyone. My name is Junsun. I'm CEO of the Pluto Labs, and thank you for coming to this session. It is truly an honor to host this session with ER&L, and I appreciate all the hundreds of librarians joining this webinar. So before we start, let me give you my background. I was a researcher in mechanical engineering, and I still write papers in computer science. After that, I founded this company, and I've been building an academic search engine and database for more than 7 years. So I understand all sides well, the research environment and bibliographic database and the AI side. Let me start with the fun fact from my own experience. Think at first. In STEM, the experimental data is almost everything in a paper. The writing just determines how well you're explaining your research. So in some case, the core contributor writes nothing at all, because they designed the research, ran the experiment, and produced the research. With the context, here's what happened to me in 2018. I published a paper in a high impact journal with a friend, and I wrote nothing. What I did was take observation data, estimate the research using deep learning, and provide that data and the figures. The data was estimated by the model, so technically it was generated by AI. But no one questioned the accuracy and no one worried about AI writing the paper, because it made sense and the data aligned with prior studies. However, today, many people worry about AI writing papers. And to me, that's really surprising. Just on that point, a quick spoiler, writing a paper that actually meets a journal's bar is close to impossible for AI at this moment. If you could do it, you could raise $400 million, because that's roughly what that kind of raise, the only company that has come closest. I will show you exactly why at the end. So even though the title of this session is Behind the AI, what I really want to deliver today is the gap between STEM researchers and everyone else, including many of you in this webinar. I mean, no offense at all, but after I started my company, this gap is the thing that surprised me most. And it's the biggest problem I want to solve. Because you are the decision maker who purchased this kind of the tool, but it's really hard to evaluate them without understanding how research works. It's nearly impossible to judge the quality of such research or what the AI says, because it is too specific and too expertized. So today I want to give you some clue about how research actually works. First, today AI is everywhere. Even my session name is contain AI in it. But from a researcher point of view, this is story from completely different world. Whenever we land an education session for our tools, Synapse and Synapse AI, I always ask the researcher in the room, are you using AI? Are you using ChatGPT or those kind of things in your actual research? And so far, not a single person has said yes. This isn't just my own biased experience. Maybe you could just checking a slide. Google Scholar traffic didn't change after ChatGPT launched, and when you look at survey data, the majority of researchers use AI only for writing things, grammar, phrasing, or coding, or testing, or just for fun, not a research. So here's today's main question. In my opinion, whether a university buys an AI product or not is almost a meaningless discussion until we answer the deeper one. Why don't researchers use AI in their research in the first place? I will give you that answer by explaining how the fundamental AI technology actually works. I've spent years on both sides of this, building the AI and doing the research, so let me walk you through it. First section is simply what is the LLM and why it breaks. I receive a lot of the question about the concerns around using AI and about hallucination. But to fully answer those, I think we first need to understand how an LLM actually works. People are assuming they already know what an LLM is. They think it truly understands, that it really knows the things. Some even believe it is smarter than human. And these days, moreover, everyone is an AI expert. There are a lot of the AI workshop everywhere, including this session. Sometimes I wonder if I should go sign up for one myself and let them teach me how my own field works. So today, very simply, let me explain how an LLM actually works. After this, you can go anywhere and show up a little in your home, in your work. Oh, I know how LLM works. And you could hosting this kind of the seminar as well in your home. The most basic level, an LLM has a dictionary of tokens. Token isn't exactly same as a word, but for now you can just think of it as a word. So it has kind of the dictionary. And the model learns the relationship between those tokens from article or over the web. From the relationship it learned, what it basically does is play a fill in the blank game. Someone asks, what is the capital of Korea? And the element responds, the capital of Korea is Seoul. But the probability is never exactly zero. So the capital of Korea is almost always Seoul, but once in a while it might say Hanyang, the old name for Seoul, because some history book uses Hanyang instead of Seoul. Or it might even say New York, because somewhere a blog wrote New York felt just like Seoul to me. That was my blog post. By the way, I've never been to New York. I hope so. Anyway, the chance is small, but it's not nothing. The second thing you need something called the vector embedding. It's not too hard to understand. For a computer to handle any kind of the data, including language, article, uh, photo, or whatever, everything has to become a number. So each token gets turned into a set of number we call a vector. And the model uses that to estimate what a word means in its context. The closer to vector set, the more related the model thinks those words are. When it builds this vector, it looks at which words show up near each other and what role each word plays in a sentence. Words that behave alike end up with similar vectors. The simplest way to put it, we say eat an apple and eat a banana all the time. Both show up in the same kind of sentence, so the model decides apple and banana must be similar things. Here's a simple diagram of the vector space. You can see the animals sit closer to each other and plots sit closer to each other as well. But here's the problem. When you get down to the research agenda level, this collapses the details because the model is just trying to find similar concepts and merge them. And undergraduate might be perfectly happy with that research, but for someone who writing paper right now, it is too general concept. So it's a meaningless. And that's one of the main reasons researchers don't use AI in their research. As a result, these two ideas, next token prediction and the vector embedding, are the basic background you need. Everything today, LLM builds on these two concepts. Now, with just these two concepts, let me explain why hallucination happens, why the model makes things up. Start with a simple question. Why does LLM almost never just say, I don't know? There are two reasons. First is training data. When someone online asks, what is the capital of Korea? Almost nobody answer, I don't know. That kind of answer barely exists in the data, so the model never really learned that I don't know is normal thing to say. Second, the way this model get tuned. The model learned that when something is outside what it actually knows, taking a guess scores better than admitting it doesn't know. It's exactly like a student on the SAT test. If there's no penalty for guessing, they guess. And this isn't just me talking. OpenAI publishing a whole paper on this, and it even made it into Nature, a very famous journal. So if you don't believe me, you have a homework to find those papers. Anyway, put those two things together. When you ask something harder, LMM doesn't stop and saying I'm not sure. It tries by a probability to generate something that looks like an answer. Here's the example. Ask only model, not today's model. What smartphone did Abraham Lincoln use? Instead of saying there were no smartphone back then, the model would answer with what is closest to what is a smartphone? Something like the iPhone 17. To be fair, neural reasoning model hallucinate less. They make fewer mistakes when they think a problem through. But even OpenAI say it's not solved. And here's the part that matters. This get worse the more specialized the topic. Uh, Frontier science concept, the exact thing your researcher care about, show up in only tiny slice of a training data. So the model has a list to go on right where it matter most. That's exactly where it makes things up. Once you see the mechanism, guess by probability instead of knowing the specific barriers that make sense, let me give you four. First, and the most important for you is fabricate reference. It embeds citation that looks completely real sounding authors, real sounding journal, a plausible year for a paper that doesn't exist. Many of you ask how to spot AI write papers or AI slop in your database. This is a source, the same guessing mechanism pointed at a citation. Second, it can't reliably reason about anything non-linguistic. A while ago, ChatGPT, that was a full old model, not too old model. But however, that model couldn't even tell you which one is bigger, 13.11 or 13.8. Because it's not really doing math, it's just predicting text. Neural reasoning models are much better at this now, and this is the point. The underlying mechanism hasn't changed. It's still predicting the task, but however, it just predicts better. Third, it agrees with you. If you push it toward an answer, it tends to go along, quietly reinforcing whatever you already believe. First, its knowledge is frozen. It only knows up to when it was trained. Anything after that, it simply doesn't have. The industry knew about all of these problems, so they tried to fix them, and that's where we go next. So now we understand how an element works and where it breaks. Let me work through techniques people built to get around those limits. This is the second section, how AI tools find the information. I got a lot of the question about this, how AI actually search, how a general tool like ChatGPT differs from specialized research tool. This section is really the answer to those kind of the question. And here the keywords explores a RAG, a vector database, agent, and inside of those, a dozen more. So I have a quick question. How many of you heard about the terminology called RAG? I want to check your reaction, but however, I can't. Anyway, uh, some of it as genuinely useful terminology, but however, some of it one older idea with a new name on it. And honestly, some of it even I look at and think, what is that supposed to mean? So let me not chasing those kind of the words today. Let me stay with what's underneath. Because all of these techniques are really doing just one thing. Remember the problem. The model generates freely from its own possibility. So everyone of this kind of the method is just way to go find real information outside the model's head and feed it in. So the model builds its answer on that instead of the guessing on their own. So when vendor tells you we use a RAG, that means we have some kind of a special method to preventing hallucination. But however, that alone tells you almost nothing because everyone uses those kind of the methodology. So I want to tell you what matter is two things. First, does it search once or do it refine? Some tools search one time and stop. Other plan search, check a result and search again, adjusting each time. So that is what people call an agentic workflow. Honestly, I'm not sure why agentic got attached to RAG, but anyway, the point is just one path or many. Second, what kind of the search does it actually learn? There are roughly three. First, keyword top end. It is basically just similar to what you are doing in Google. The AI generates the query and search and pulls the information from the top 10 or top 15 results. It is fine for general concept, but if you need verify something exists or not, or you want to find precise specific concept, it fails a lot. The second, user vector database. Instead of matching keyword, it used those vector I described to find similar document and summarize them. Think of it as the same thing, but with the keyword swap for the vector. So it cached more the context because the vector containing some kind of the context. But however, a bit better, but however, the limitation is the same one I showed you in the keyword search. It collapses and moreover, it is using the vector things, it collapses the precise distinction. The third, user graph. For a paper, this kind of the graph usually maps paper to other things. Its authors, the material it mentions, related keywords, and work outward from there. It depends heavily on where you start, and even more on how that database was designed. Keep that one in mind because in a second I will show you the graph that built differently, one that maps the paper to each other. Same idea, graph, but different kind pointed at different goal. So there are kind of search out there. Takeaway is simple. When the vendor say we use lag, so no hallucination, that's not an answer. Ask them two things. Does it search once or refine? And which kind of the search does it run? And one more, remember, just can't do it is not meaning does it well. So ask real question, what secret sauce did you add to make it working well? That's exactly what separates one tool from the other tools. So let me tell you about our secret sauce. And fair warning, this is the only time today I'm going to talk about our product dimly. Uh, It's honestly the most important part I have to do in this whole webinar, so please bear with me. Otherwise, Sana, our CRO, is going to come after me. So here is how we thought about it. Whether it's an LLM or an AI agent, the root problem is the same one a researcher hits on Google Scholar. Why is it so hard to find the right paper? Remember the problem I showed you before. Papers share a huge amount of keywords and looks very similar to each other. So back to embedding keywords or those kind of the method has failed to find the white paper in a really short time. So data like that every day struggles on the same way. Human, an AI agent, LLM, doesn't matter. They have a struggle to find white paper in the database. We solved it with a citation web. So it's quite different from the graph I mentioned in graph back, the one that maps the paper to author's material keyword. So ours maps the paper to each other paper, who cited whom. And the important part is this graph already exists. We don't reconstruct with the model, and researcher build it themselves every time they cited paper. So there's nothing here for the AI to make up. But here's the real point. It isn't just that we have a citation graph. Anyone can count citation across the whole database. What different is where we count. Look at the network on the left. When a question come in, we pull out only the paper in that corner of a field and draw the citation graph from just that set on the spot. And when you close the paper, how they cite each other, something appear, the agenda inside the top field, the specific problems, problem groups are actually working on. You can see them here, something like energy storage, solar thermal, silicon efficiency. Those clusters aren't labeled with type in. They emerging from a citation structure itself. Then the middle part, we wrap that in on agentic workflow. The AI plans which paper to target, search across the network, check if that's enough, and refine it if it's not. Not one shot, it works the problem. And because we redraw this graph every single question from scratch and not cache it, we can give you something others can't. Look at right side. Normally, all you get is paper's total citation count, how cited it is in the whole academic world. We can tell you how many times it was cited inside a specific field or inside a specific region, specific country, or those kind of things in a real time. And that matters more than it sounds. A paper with 50 citation in a small field can carry more weight than one with 5,000 scattered across all of the science. Total count hides that. We narrow it down into the field and into the region. So one question is wrapped. Why citations? Why is citation such a special signal? You can get it once you can see how researcher actually uses one. First, a citation isn't just saying here's something related. It means you built your own work on top of the paper. You trust it and you stood on it for your next step, so the citation carries weight. If that paper turns out wrong, your work shake too. Second, so when a paper gets cited again and again over years by groups that don't know each other, that's not a popularity. It means the field kept building on it, and it held works get proven wrong, then slowly loses its place. Which means in the end, the citation graph is built on record of what it stands on, and it corrects itself over time. But let me be honest about one thing, because it matters. Citation is not stamp of quality. One citation is not proof, and some famous, highly cited papers still turn out to be wrong. We know that. So here's what we actually measure, not a low number of citations, but whether a paper holds its place over time. Better results get dropped, as only one keeps getting built on. So this isn't guarantee of truth, it's a signal, strong one, of what a field actually standing on. Last one, earlier I talked about the agent in search, a multi-pass step, but however, the next thing is different. It's agent across the research workflow. So my last section is where AI actually fits. It means where is the point that AI can help the researcher. Likewise, other sections, here's a related question from yours. From this section, I will introduce some research workflow and the rubric for the selecting right AI tools for the research. I will start this section with the keyword that AI agent. These days, AI agent has basically becoming one word. Everyone says it, agent, agent. Sometimes I wonder if there's an actual reader secret agent living inside of AI model. And the funny thing is, everybody means something different by it. Ask 10 people, you can get 10 different definition of AI agent. So as a label, it has kind of stopped telling you anything. So let me do something I did with RAG. Put the word down, start instead from what researchers actually do, the real work, and then ask two questions. One, which piece of work can AI even take? Two, and does it do it well? Because can do it is not meaning does it doing well. So that two terminology is very different. So you have to check in those kind of the gap. So, and by the way, this same range isn't just for the research tool. It works for your own work too, like metadata, cataloging, reporting. You have to ask the same question for any kind of the AI tool. So disconnect back to what I asked at the very beginning, where the researcher actually need AI's help. Let me show you the workflow. I will show you what research actually does, not one thing. It is simplified, but however, only 16 different jobs. It starts in knowing you frame a research question, search the paper, track where the field is going, judging what to trust, the map the structure, find the gap, and then doing the real science work. So the form a hypothesis and checking the novelty and design the experiment, run it, collect data, analyze it, build a model, interpret, and pull out the key finding, and finally telling the white paper, make the figures, and answer the review. So look at how many steps that is. So when someone says AI does your research, ask which of these sections because no tool does all this kind of the workflow. Now the blue boxes, that's where we work. We cover this part of knowing and hypothesis, checking part of the doing. That's it. We don't run maybe researchers experiment. We don't write the paper. And I'm showing you this for a reason. This whole map is kind of the ruler. So put any tool you want to evaluating, you could using this kind of the workflow. So those 16 jobs fall into the three big modes: knowing what's already known, find the work, adjusting what to trust, mapping the field, spot the gaps. So this is all the information retrieval. So, and it's where AI generally can do something well in this area. And next one, the doing, the making new knowledge, the maybe real, the body of the research, hypothesis, experiment, data, and analysis. This is mostly the researcher part. And yeah, giving some kind of material for this section, but however, AI cannot do experiment at this moment. And the final section is telling, communicating it. So writing, answering review, AI help with the grammar and writing something. But like I said at the start, that's not where science happens. Now, here's the part that matters. The body is doing, but what actually enlarges the researcher is when knowing voice doing breaks. So you can just imagine you spend 3 months on a question someone already answered, or you chase maybe a hypothesis that never had a chance. That's a really expensive failure. So doing well isn't nice to have. It prevents most painful waste in the research. That's why I keep hammering on the information retrieval and knowing section. So, and here is maybe two maybe key questions. Keep them in your pocket when you evaluate the AI research tool, including ours. Everyone says their tool is the best. These two cut through all of that. One, how does it find the information? This is everything we covered in the second section. Is it matching surface similarity or using the real structure of how field is built? What's the corpus and who curated? And the big one for you, can every claim trace back to a real source? You can actually check. If a tool can answer that, you already know the maybe answer. Two, does it know its place? Which part of the workflow does it actually do, and how well? Remember, it is different that can do it and maybe do it really well. And a tool that claims to do everything is telling you it doesn't understand this kind of the whole workflow. Real research has a lot of the workflow, and nothing just maybe a simple workflow like find a paper and maybe summarizing it or those kind of things. And maybe this is my next slide. And remember the spoiler from the very beginning of this session. So I said a paper that meets a journal bar is right now is impossible for the AI. So I will show you the reason why, and maybe I will explain a little details about the AI writing paper. So here it is. There is some kind of example, a real case I want to talking about in this section. Sakana's AI scientist. And I want to be precise this case with some kind of the details. So that case is the only fully AI written paper did pass a peer review, just one time. Quick context first. In computer science, the top conferences are the real bar. So their main track is just as hard as a journal, sometimes more harder than journal. Below that sit the workshop, much easier, more experimental. So where did this paper get in is the workshop, not the main track, not the journal. And it is kind of the entry level. And even there, the score was 6.33. So just barely over the line. It was run as an agreed experiment with the organizer corporation, and they withdrew it before publication. One more thing, it was in computer science for a reason. So there, the experiment is just code, so it can all run inside a computer. So in your research field, the experiment is, in most of the cases, is physical. AI can't even run it. So there's Honest Red, one of the best funded AI labs in the world, around $400 million, got an AI paper over by exactly once, a workshop with the help of Bailey, and then pulled it. That's not AI doing research at most. It imitated the writing. The experiment the data, the real contribution that's still for the researcher, which is the whole talk. In one example, AI can help the researcher, but however, at this moment, it does not do research instead of researchers. So let me pull the whole things together. Three things to key takeaway with you. One, what LLM is just next word predictor, a powerful but but as only just guesses, it gets worse exactly where research lives, the precise, the new, the edge case. So low LLM by itself is not a research tool. Two, the why RAG exists. Every serious tool wraps a model to go find the real information instead of guessing. So the question is never does it use AI, it how does it find it and what their secret sauce. Third, how you evaluate the AI tools are two questions. How does it find the information? And can every claim trace back to real source? And does it know its place? Which part of the work does it do and how well? So this is the end of presentation I prepared. And now let's move on to Q&A session. I love to take your question about maybe 10 to maybe about 10 minutes.
You know what? We actually we're running out of time. The great news is there's been submitted a lot of great questions and Sanha has answered a lot of them. There's a few he's saving for you. And
Oh,
we'll definitely get back. We're going to send everyone the transcript so they can see the questions and the answers. So all the audience and everyone can see that. But we only have 12 minutes left on this webinar. Or no, I'm sorry, we have a little bit longer than that. I was thinking it was 1 hour. So I think, I think there's why don't we go ahead and answer one or two actually. A few that were saved for you. Let's see. We have, how are you determining what fields a paper belongs to? Can a single paper belong to multiple fields? And are you
uh,
removing self-citations?
so it's the first question, right?
Yes.
Yeah. So determine field. Yeah. So in case of that, there's no definition of field. So when the researcher input the keywords on that, so we are um expanding the query using the synonym of the keyword or those kind of things, and then define the set of the paper which containing those kind of the terminology. So it is hard to explaining, but however, just for example, so if you type in that uh, maybe deep running this. So then maybe we generate some kind of the query that deep learning and uh, deep neural network and maybe AI with the deep learning or the AI deep learning the vision model or those kind of things. And then there exists some kind of the any kind of the terminology of those kind of the maybe any kind of the paper containing those kind of the terminology, we are defining the paper is belong to this kind of the agenda. So dynamically, it changes by what kind of the keyword the user input. So, and the second one is that uh, are you removing self-citation, right? So basically, in we, so if someone who write a lot of the paper in that field, or we are not removing self citation, we just counting the self citation on specific field, so not related to maybe the other. But however, someone who want to remove the all citation, all self citation in that field, we could provide those kind of the option when they build those kind of the query. Yeah,
Okay.
yeah,
Um,
yeah.
thank you for answering that. I so like I said, Sanha answered a lot of questions. Haley or Sanha, is there any of these questions that you all have answered that you would like to bring to Jun-sun specifically while we have a couple more minutes?
Hi. I think UCCS from UCCS have asked. I understand that RAG is more efficient. I think Jason can answer that. Did you
What
see
what
it?
what is the questions? UCCL?
Yep. You see from UCCS. If you see the chatting, you can
Um,
see. I
uh,
understand that RAG is more efficient than LLMs, and that one.
yeah, redesign but when using
Yep.
RAG-based AI can repeat it identical question produce similar but not exactly same result, or do the result and reference change randomly over time? So this is maybe question about why even the using the RAG and but however changing the result when they are typing again or with the same query, right? So and I think that is the limitation of a RAG. So the any kind of the RAG they starting with the search, starting search with the generated query. It is the generated by AI, so it is not exactly same at the over time. So when you ask same thing to ChatGPT or the Claude or whatever, they always ask differently. So even they are using RAG, but however, when you're the maybe typing something, they searching different things. So that result with that get different maybe top 10 result or top 50 result, and that as a result that give you the different answer. So when you even you are using lag, if you are asking some kind of the general concept, or if you are asking uh, some kind of the concept have a lot of the document, they can deliver you, even it is grounded, but however, with different explanation. Yeah. Is it enough to the answer for this question?
Yeah, I think that was good.
Yeah.
So like I said, we will gather all these the questions and answers and share them with everyone. I think right now uh, we will go ahead and transition over to Sanha, who will be doing part two of this webinar. Thank you.
Um, yes. Okay, so before to closing, can I maybe answer the maybe recent question that the synapse based is answer on full text or just abstract of the papers?
Sure. Yeah,
Is it
go
okay? Yeah,
ahead.
yeah. So basically, we have a lot of the full text data, but however, the element the by the mechanistically, so a lot of the text input for them, they giving the low graded the answer. So but however, in the paper, there is a lot of the noise. So in especially in stem pill, maybe one or two paragraph is a core part of a paper. But however, LMM just consider every the section has a equally maybe important section. So they cannot understand well with the full text either. So maybe short answer, we are only using the title and abstract, and we prefer to using uh, only title in some case because abstract they contain the noise. But however, even we have the pretext data, we are very feed into the model because it is too big data for the LMM to handle it. So we always not feeding all the data. So we just using abstract. In some cases, we just using the conclusion section from the pretext data. Yeah,
Okay.
and this is okay.
Okay. That's great. Thank you so much.
Okay, thank you so much as well.
Okay, we're going to turn it over to Sanhan now.
Yeah.
Okay. Let me just share the screen. Okay. Yep. Okay. Uh, Hello, dear librarians. My name is Sanha Kim, Chief Revenue Officer at Polito Labs. Welcome, and thank you for joining today's webinar. To briefly introduce myself, I am someone who spends every day thinking about how to bring meaningful, genuinely helpful products to researchers and libraries in the academic world, and how we can all create win-win outcomes together. And a more personal note, I am a father of a wonderful 4-year-old daughter who always cheers me on, and of a second child in the way. Between my first daughter, who already keeps me in line with plenty of advice, and my second daughter, who I am sure will do the same soon enough, I am someone who finds happiness in the small things and enjoys each day as it comes. I'm glad to be able to introduce myself even briefly, and I thank you all for joining Pluto Labs webinar today. So while my partner Jinsun covered how researchers are using AI and the technical side of LLMs and RAG-based tools, I would like to talk about libraries in the age of AI. And the topic I expect is most on your mind as librarians, AI literacy. Here is our roadmap. First, the current situation, why this matters now. Second, what AI literacy actually means. Third, the four core domains, understanding, application, evaluation, and ethics. And finally, how you as information professionals can step into a new role as trusted guides. So beyond that, I would like to share some thoughts on how you as information professionals can embrace this change and can step into a new role as trusted guides in the age of AI. As you know, this period of rapid change and our unavoidable coexistence with AI is having a major impact on the academic world. I believe companies like ours should take a more active role in guiding you and helping you understand these changes, and that we should do so transparently. Just as libraries once adapted from a time when papers were read only on paper to an era of reading them online. I'm confident we will adapt well to this next shift in phase. Today's session will not cover everything, so if any further questions come up afterward, please feel free to reach out anytime. While some of you may already be well versed in AI literacy, others may find that the concepts feel familiar in theory but less settled in practice. Today, we'll focus on the fundamental core elements, not because the basics are simple, but because a strong foundation is what makes everything else hold. This session of AI literacy won't be covering advanced topics. It's designed around the foundational concepts that everything else builds on. Some of this may already be familiar to you, and that's completely fine. I believe that in any field, how well you grounded yourself in the basics ultimately determines how far you can go. So rather than treating this as new information to absorb, I'd invite you to let it wash over you, the way you might listen to music you already know. So over the past few years, ChatGPT, Claude, and Gemini, alongside a wave of paper summarization and analysis tools, have rapidly appeared in our life. So when we see it, AI isn't a distant future topic anymore. It's already here in people's daily lives and increasingly in the conversation happening inside like academic libraries. You've probably noticed it yourself. The questions are changing, the requests are changing, something has shifted. And I think it's worth pausing to look at what's actually happening before we talk about what to do about it. So let's look at where this shift is showing up. First, in everyday life, tools like ChatGPT, Copilot, and Gemini have become as routine as Google search for many people. The students use them to draft, summarize, brainstorm. It has become mainstream. Second, in research, the most common use case, grammar correction and parsing English. But beyond that, researchers are slowly starting to explore literature search, summarizing papers, generating ideas with academic AI tools. The range is expanding, even if adoption isn't uniform across fields. And third, libraries. AI-related questions and requests from patrons are increasing. Whether libraries have formally adopted AI tools or not, the shift is already arriving at the reference desk. The point isn't that everyone is an AI power user. The point is that the direction is clear and it's not reversing. So what does this look like on the ground? Specifically for libraries, requests to evaluate and adopt AI tools are coming in steadily from faculty, from students, from administration. And by the time a library has assessed the one tool, another has already appeared. The landscape moves faster than procurement cycles. At the same time, patrons are arriving having already used these tools, and they are starting to ask librarians for guidance, not just what database should I use, but is this AI output reliable? How do I cite this? Can I trust what it found? So in fact, according to recent research, 87% of researchers in this case, library users, have concern about AI, mostly hallucination, inaccuracy, and privacy. And 57% say the real barrier is simply not having guidance on how to use it responsibly. So ultimately, AI become hot topic for library too. So here's the question that frames the rest of today. How should librarians respond to this change? To answer it, let's first clarify one concept, AI literacy. Let's define our term. This will be familiar to you as librarians. Literacy has expanded with each era, and AI literacy is simply the newest chapter. First, basic literacy, the basic ability to read and write, the most fundamental competency for understanding and expressing written language. Then, digital literacy, the ability to search for, create, and share information using digital devices and tools such as computers, smartphones, and the internet. It emerged with the spread of internet in the 1990s. Then information literacy, the ACRL framework of 2015, going beyond finding information to critically judging its value, context, and credibility. And now AI literacy. So what is AI literacy? Honestly, the definition is still being written, and even where institutions have defined it, it keeps being updated. At Pluto Labs, we define it as the ability to go beyond simply knowing how to use AI, to understand its mechanisms, limitations, applications, and ethics, and to use it critically. Crucially, it builds on the ACRL framework you already know. It is an extension of information literacy, not a replacement. So there are many different views and standards of defining AI literacy today, but the AI literacy that I believe libraries should keep in mind and use as a benchmark comes down to four core domains. And as the session goes on, I would ask you to keep in mind that AI literacy is not a replacement for information literacy, but an extension of it. Our framework has four domains. One, understanding how does AI work? Two, application, how do we use it well? And what are the limits? Three, evaluation, can we critically judge its outputs? Four, ethics, do we use it responsibly? Among these, the heart of literacy is the ability to critically evaluate the source and credibility of information, the area where librarians can give the most valuable guidance. The first domain, understanding. When a service is adopted at the institutional level, the library carries much of the work, and without a basic grasp of AI, knowing how to even approach it can feel overwhelming. So when a service opens at the institutional level, rather than being bought individually, the library does much of the work, and librarians play a crucial role, tool evaluation, Is it suitable academically? Security review. Are students and research data safe? License review. Cost, scope, legal responsibility, and educational support, guiding faculty and students. These are detailed, time-consuming tasks that must be done carefully. Without an understanding of AI, knowing how to approach them feels overwhelming. Since my partner Junsen just covered how AI actually works in detail, I'm not going to repeat all of that, but I want to walk through the same core ideas one more time in a simpler way. Let me keep this simple. AI is the broadest term, computer technology that learns to judge is like a human. Through machine learning and deep learning, the form we meet most today is generative AI. And the flagship of generative AI is the large language model, the LLM, ChatGPT, Cloud, Gemini, being the everyday examples. An LLM is a system that learns from an enormous amount of text and statistically predicts the most plausible next word given a context. The key point here is that it does not search for facts. It generates a plausible next word. Just understanding this much lets you easily grasp the concept and working of generative AI. So we have now reviewed, quite simply, how an LLM works, what it outputs, and I have briefly put source traceability and hallucination in this page. So let's keep going. Now onto application. How can we use AI tools effectively, and what are their strengths and limitations? We need to be clear about this. So generative AI is genuinely good at three things: explaining concepts, suggesting structure, and policing language. And the reason is actually the same in all three cases. It's seen an enormous amount of human written text that already does these things well. Explanations, structured document, natural sentences, all of that is baked into its parameters. So when you ask it to simplify a concept, organize an outline, or clean up your writing, it's not being creative. It's reproducing patterns it's already seen millions of times. So that's its strength. And understanding that is also key to knowing where it falls short. All three limitations comes from the same root cause. LLMs don't retrieve facts. They predict plausible text. Everything else follows from that. Hallucination. It has no concept of true or false. It just generates what sounds right, which means it can confidently produce fake citation, non-existent papers, and made-up statistics. The danger isn't just that it's wrong, it's that it sounds certain. Source and time blindness. Difficult to trace where an answer came from, and its knowledge is frozen at the point of training. It knows nothing that came after. Users are left to verify on their own. Bias. It learned from internet text, which skews heavily toward English, Western perspectives, and majority viewpoints. Minority languages, non-mainstream disciplines, underrepresented voices, these are all underrepresented in its outputs too, not by intention, but by design. So in short, generative AI is very useful for reconstructing known patterns, explaining, structuring, policing, but particular caution is needed for verifying facts, the latest information, citation critical academic work, and minority languages or sensitive topics because hallucination, opacity, and bias all operate at once there. The golden rule: use it to expand your thinking, never as the final authority on facts, and always cross-check the original source. The third domain, evaluation. Critically checking AI's output is not difficult, just tedious. But the tedium is the last line of defense for academic integrity. I propose a simple four-step checklist, CSEB, to run before accepting any LLM answer. C. Cross-check. Does the cited word actually exist? Source verification. Is the basis traceable? Epistemic limits. How current is the information and whose view is it? Bias awareness. Whose perspective is missing? Let's look at each. So step one, cross-check. Verify cited papers, authors, and statistics in primary sources. For example, from any of your subscription databases to Synapse, Google Scholar, and PubMed. If a study can't be found or a DOI fails, it's likely a hallucination. Step 2. Source verification. Ask for the source, then open it yourself and confirm the claim is there. Watch for the fabricated citation. As you can see from the example, every detail sounded natural. That is what makes hallucination dangerous. It looks right, not wrong. Epistemic limits. LLMs have a hard cutoff. They know nothing after their training date. So in fast-moving fields like science, engineering, medicine, law, AI, or climate science, always supplement with primary sources from the last 1 to 2 years. And watch out for the phrase, according to recent research. The model has no idea what recent means. Bias awareness. Answers default to English-speaking Western majority viewpoints. This isn't just about stereotypes. It shapes what gets treated as authoritative. Ask an LLM for the most influential education scholar, and it will lead with maybe Anglo-American names. Figures like Paulo Freire or Manabu Sato, genuinely influential, just not in the Western academic circles, tend to get deprioritized, not because they are obscure, but because the model's definition of influential was shaped by biased data. So actively ask for what's missing. What are non-Western perspectives on this? Who else is influential in this field outside of the US and Europe? Push the model toward the edges of its defaults. So here's a checklist for students and researchers to apply every time. Does the cited material exist? Does it really contain that content? Is it current with a clear time frame? Are other viewpoints missing? The key message, an LLM's answer is a starting point, not an end point. The researcher's job is the very process of verifying that draft against primary sources. So the bottom line of evaluation, believe only what you have verified yourself, not simply what the AI says. Human review is essential, and human needs to review the output, even if you used generative AI only minimally. That is the key point of this whole domain. So it is precisely because of these risks that academic database-based AI tools take a different approach from general purpose LLMs. They connect an LLM to their own verified database of papers so that rather than inventing new text, the tool searches for and retrieves paper that actually exist. In other words, providing outputs whose sources can be traced and verified is the biggest difference from a general LLM. You may already know this, but recognizing this point once more will surely help you make better use of AI tools. Of course, whether the retrieved paper is genuinely a highly relevant document and whether it is free of the bias mentioned earlier depends on each tool's technical capability, and that is a separate matter. So far, we have looked at how to understand AI, how to use it, and how to critically evaluate. Now comes the final and most important stage, ethics. What you can do and what you should do are different things. True literacy in the age of AI is completed not by the ability to handle the technology, but by the attitude of using it responsibly. So why ethics comes last yet must be considered first. AI is powerful, and so the consequences of its use affect an individual's academic credibility, the rights of others, and the entire knowledge ecosystem of society. No matter how strong one's verification and application skills are, without ethical sensitivity, those skills can become a tool that creates even greater harm. This is the most fundamental reason libraries and universities must teach AI literacy. So academic integrity, the core principle is simple. AI is a tool, not a co-author. Major publishers and Committee on Publication Ethics already require that LLMs cannot be listed as authors and that any use be disclosed in the methods or acknowledgements. So what needs disclosure? Any text actually generated by AI, What doesn't? Basic grammar or spell check. A, dis a good disclosure statement names the tool, limits the stated use case, and makes clear the science is yours. Two things to check before submitting. Some journals like Nature or Science have their own required format for AI disclosure, so verify that first. And if you used AI for more than language cleanup, structuring arguments, summarizing literature, update the statement to reflect that accurately. So copyright and attribution. Two things to know upfront. Copyright in AI generated output varies by countries. For example, under current US and Korean standards, purely AI generated output is not granted copyright, and the legal landscape is still largely unsettled. The more important question isn't whether AI used someone's data, it's whether the original author's contribution stays visible. So there are two fundamentally different models: absorb, regenerate. How general purpose LLMs work. Training data gets compressed into parameters. The output is a recombination of countless sources, but no source is visible and no credit goes back to the original author. Copy that output as is, and you may be committing plagiarism without realizing it. So index and link back. How search engines, academic databases, and libraries have always worked. Content is made discoverable, but always links back to the original. The author's contribution stays visible. Users can return to the source. The ethical core. Plagiarism isn't about using information. It's about making someone's contribution invisible. If the source is preserved and traceable, it's legitimate discovery. If it isn't, it's a violation, regardless of whether a human or an AI generated the text. Third, privacy. Where does what you enter into an LLM go? Data in free public LLMs may be reused for training. Be very cautious about entering personal data or student records, unpublished research, confidential files, or colleagues, manuscripts under review. Institutions should adopt secure institutional LLMs with opt-out of training options or choose academically focused services like Synapse AI with contractual no training terms. Ethics come down to two words: reflect and respect. Reflect. Before using AI, ask yourself three questions. Can I disclose this transparently? Does it infringe anyone's right? Am I okay if my input is exposed? All three needs to be yes. Respect. Three principles. AI adds thinking, but is never the thinker. Cite the human authors behind every answer, and protect the knowledge ecosystem that scholarship depends on. The final stage of AI literacy is knowing how to use it well. It's knowing how to take responsibility. So understanding, using, evaluating, and finally ethics, reflecting and respecting. That's what it means to be a scholarly citizen in the age of AI. So today we followed four words: understand, use, evaluate, and ethics. Understand what AI is and why it produces what it does. Use its strengths without forgetting its limits. Evaluate, doubt, check, verify, and reflect and respect. Take responsibility, respect others, and the knowledge ecosystem. These four are not checklists, they are the fundamental foundation of shaping a new scholarly citizenship for students and researchers. And finally, if I had to sum it up in one sentence, AI gives answers, but teaching good questions, prompting people to doubt and verify those answers, and guiding them to take responsibility for their use, this is still the work of people, and it is a role you can fulfill. Of course, going deeper into what I have shared today would expand into an academic field in its own right, and it would be hard to cover all of it in such a short time. But even if you simply remember the broad flow I have shared, understand, use, evaluate, and ethics that reflect and respect, I believe it will have been a meaningful session for designing around the foundational concepts that everything else builds on. Simple as they are, These four words ultimately capture the essence of the message that librarians and libraries should pass on to students and researchers. At Pluto Labs, we are not simply a company that makes AI tools. Together with libraries and with you, our librarians, we want to be a partner in building an academic environment that students and researchers can trust. The values you have long upheld, trust, verification, and academic integrity, we will support with our technology and tools so that those values can carry on into the age of AI. A good tool ultimately delivers its true value only on the foundation of a good relationship. I sincerely hope today's time together becomes the starting point of that good relationship. So now the Q&A time. Before the webinar, we received a number of pre-submitted questions. Given the time constraints, we wanted to address some of the most common ones in advance, particularly those that reflect broader questions we are hearing across the librarian community. So, excuse me. So the first question was from the Emory University Library. We need to know how it can be used to enable us to do better, more and faster for our users, and what its limitations are. The ethical, legal, and political aspects are important too. What do we need to guard against personally in dealing with our vendors and for our missions? Vendors and for our missions. So my answer was, I think that's exactly the conversation institutions should be having right now. The question is not simply whether AI works, but how it can be used responsibly and effectively to advance the mission of the institution. From a practical perspective, AI has the potential to help researchers, students, and information professionals accomplish more in less time. It can accelerate literature discovery, help identify relevant papers across disciplines, surface connections that may otherwise be missed, summarize large volumes of information, and reduce the administrative burden associated with early stage research. For librarians and research support teams, AI may also help scale services that would otherwise be difficult to provide consistently across growing user populations. However, the value of AI should not be measured solely by speed. A faster workflow is only beneficial if it also improves decision making and research quality. The most successful applications of AI are likely to be those that augment human expertise rather than replace it. So at the same time, understanding the limitation of AI is just as important as understanding its capabilities. AI systems can generate inaccurate information, overlook important context, misinterpret nuanced research findings, or present uncertain conclusions with unwarranted confidence. For this reason, AI-generated outputs should be viewed as decision support tools rather than authoritative answers. Human review, subject expertise, and critical evaluation remain essential. The ethical and legal considerations are equally important. Institutions should carefully evaluate how vendors collect, store, and process user data. Questions around privacy, intellectual property, transparency, security, and data ownership should be addressed before deployment. Organizations should also understand other information retained, how it may be used, whether it contributes to model training, and what controls exist to protect sensitive or proprietary content. There are also broader institutional questions to consider. How AI affects information literacy? Does it encourage critical thinking or discourage it? Does it improve access to knowledge for all users? Or does it create new forms of inequity? How can institutions ensure that AI recommendations are transparent and accountable? These questions are particularly important for university and libraries whose mission are rooted in education, discovery, and public trust. When working with AI vendors, I believe institutions should ask three fundamental questions. What problems does this tool genuinely solve for our users? What are the limitations and risks of relying on it? What safeguards exist to ensure that its use align with our institutional values and responsibilities? So in that sense, AI should be viewed not as a replacement for researchers, librarians, or educators, but as a tool that can help them focus more of their time, expertise on the work that matters most. Well, I hope I answered well to this question. The second one, I'll make it brief. Now, the second question was how to stem the tide of AI-generated slop invading library database from Accenture University. So I believe this is also a very important question and also at the same time difficult to directly answer, especially from vendor side. That said, I want to be honest about where I think things are heading. I don't think we can realistically win a long-term battle by simply trying to detect AI-generated content. Detection tools will improve, AI models will improve, then detection tools will improve again. It quickly becomes an endless arms race. Instead, I think libraries, publishers, and information providers should shift focus to signals that are much harder to fake: evidence, citation, transparency, review processes, and scholarly reputation. In many ways, I think we are asking the wrong question. The question shouldn't be, was AI involved? Increasingly, AI will be involved in many aspects of writing, editing, and research workflows. A more useful question is, why should I trust this? Can I verify the claims? Can I trace them back to credible sources? Can I understand how the conclusion were reached? Those are the kinds of questions that remain important, regardless of whether the content was written by human, assisted by AI, or generated by AI. So ultimately, I think the real challenge isn't that AI can generate content, it's that AI can generate content faster than people can evaluate it. That makes the role of libraries, publisher, and trusted discovery systems even more important, not as gatekeepers of information, but as guides helping users navigate an increasingly complex information landscape. Okay, the last, beyond learning about AI, what are the next steps for library staff to employ these tools? So I think the next step is to start experimenting with it in low risk, practical ways. Many library professionals feel pressure to become AI experts overnight, but I don't think that's necessary. Most of us didn't become database experts by reading about databases. We learned by using them. The same is likely true for AI. A good starting point might be asking which tasks take up a lot of time but require relatively little judgment, which workflows involve repetitive searching, summarizing, organizing, or drafting. Where are staff spending hours gathering information that could be gathered in minutes? Those are often good candidates for experimentation. For example, library staff might explore using AI to draft meeting notes or summarize, generate first drafts of instructional materials, brainstorm workshop ideas, compare vendor documentation, summarize policy documents, develop search strategies, create training materials or patterns. At the same time, I would encourage staff to use these tools critically. Don't just ask whether AI saves time. Ask whether the output is accurate, useful, and appropriate for the task. And if you are still not sure where to start or how to evaluate a particular platform, come find me. I'd be more than happy to continue the conversation and think through it together. So now I think I'm done for Q&A. I'm sorry, apologies for not able to answer all of your questions, especially within the short time of period, but we are more than welcome to answer your questions after the webinar. Okay.
Thank you, Sanha. That was really great and really helpful. I know for me, like I've learned a lot both on the technical side and also thinking through some of these AI literacy related concerns and questions. As I said at the beginning, ER&L and Pluto Labs both want to help librarians um, uh, understand this area and think about, our roles. And this was really a phenomenal way to start that conversation. So look for stuff from us. coming soon. And thank you all. And yes, if there's any additional questions, we will get those to the right speaker and get back to you and share the questions and answers that others have had. Thanks again for joining, and you'll see more about AI from us soon. Thanks, everyone.
Thank you. Thank you, everyone.